Today we're going to be talking about how to compare irrational numbers to rational numbers, comparing them by putting them in order from least to greatest, or greatest to least. Okay? When they're asking me to compare numbers, they're asking which one's bigger, which one's smaller, or are they equal to each other? That's what they're asking. Okay? So, in order to do that, we've got to understand just a very general concept of what we did the first day we opened up this particular packet, how to estimate a square root. So let's take a look at, in the reflect section, the square root of 300. Okay? When we're estimating this, again, it helps if you know your perfect squares. Now, I'm not going to start at 1 squared, because 12 squared is what? 144. I'm not near there yet, am I? What's 13 squared? 169. What's 14 squared? 196. What's 15 squared? I'm still not there yet, am I? 16 squared. What is 16 squared? What is 17 squared? And 18 squared?
324.
Now, what it asked me was, between what two integers is the square root of 300? It's going to fit right in here somewhere, so it's between 17 and 18. Which is it closer to, just out of curiosity? 17. It's 11 away here, it's 24 away here, so it's definitely closer to 17. So it's like 17.3, maybe 17.4. Somebody put in the square root of 300 on their calculator. 17.32. Okay? We don't have to be 100% accurate to compare. We just need to know an approximate value and how to find that relatively quickly. So having a list somewhere that you could reference might be a good idea, but starting to memorize those perfect squares is a really good idea, especially through 15. Because as you continue in school, although you may never have to estimate a square root again, you will end up having to simplify square roots, and it's using the same table to do it. So you're going to keep seeing the concept of this perfect square over and over again. Questions so far on what we've talked about? So let's look at the year terms there at the bottom of the page, where they're asking me to compare the square root of 2 plus 4 and 2 plus the square root of 4. And in the space, they want me to write less than, greater than, or equal to. They want me to compare them. Okay. What is the square root of 4? 2. So on this side, this actually is easy to calculate. That's a total of what? 4. In this particular case, do I even need to approximate what the square root of 2 is? Because if I take 4 and add something to it, what just happened? This side got what? Bigger than this side. The square root of 2 is about 1.4. So this would have been about 5.4. But I knew it was between 1 and 2 somewhere. But he's still okay? This one isn't quite as easy because I can't take the square root of 12, can I? What is the square root of 12 between? It's between the square root of 9 and the square root of 16, right? So it's between 3 and 4. Which is it closer to? It's a little closer to 16. So for the sake of argument, since this is between 3 and 4, let's use 3.5 plus 6. What is this going to be? Do I need to go any further? Do I need to estimate the square root of 6 on the other side? No, because this is already 12, and I know that 12 is bigger than the 9.5. But it's still okay? Understand what we're doing. What type of number is the square root of 12? Irrational. What type of number is the square root of 4? It is whole, because the square root of 4 has a value of 2. Order the numbers from least to greatest, then graph them on the number line. Okay? And again, notice they're just getting us to the nearest what? 10th. Right? If I'm somewhere in the nearest 10th, actually they're in halves, but if I get to the nearest 10th, it's going to be easy to decide. So, the square root of 5. How would I estimate that? In my list, what's on each side? The square root of 4 and the square root of 9. So I know it's between 2 and 3. Which is it closer to? It's closer to the 4 than it is to the 9, so it's closer to 2. It is definitely less than what? 2.5. So 2.5 is definitely bigger. By the way, do I need to even calculate the square root of 3 then? I do, to figure out where it is on this number line, but I know the square root of 3 is the least, and the 2.5 is the greatest. So, if they want me to organize them from least to greatest, it would start out with the square root of 3. Then it would be the square root of 5, and then it would be 2.5. 2.5 is easy to graph. The square root of 5, we already said, is going to be between 2 and 2.5, so I might put it in here. Now, the square root of 3. What is it between? It's between 1 and 4, right? Which is it closer to? 4. So it's between 1 and 2, but definitely above 1.5. So the square root of 3 would be in here. But it's still okay? Question?
If we know how to find the square root without the calculator, is it alright if we still use it for the questions?
No, the whole goal is that you do this without what? A calculator. That's the whole goal, so you could look at them and determine how to do it. Okay? Now, do I mind if you check your answer with a calculator? No, I don't care. It's all right. But just to be able to punch that into a calculator is not testing what this really would want you to test. When we get ready to take the quiz on Thursday, do you think I'm going to let you use a calculator? I'm not going to have a calculator on Thursday, because this is a section we're supposed to be able to do without one. Okay? Pi squared. What's 3 times 3? 9. So it's going to be more than 9, but probably not to 10 yet. 9.2, 9.3, 9.4, 9.5. Yeah, if you use more digits of pi, right?
But if you
If you use that. But if you only use 3.14, what did it come up to?
9.85.
9.8. Okay? So definitely, still, no matter what, less than what? Less than 10. Okay? Square root of 75. Again, you've got to know the list of perfect squares. What's on each side of it? 81 is on one side, and 64 is on the other side. This would be 8 and 9. Okay? Which is it closer to? It's definitely a little closer to the 9, so it's above 8.5. Do I need to go any further, though? No. It's above 8.5, so it's between 8.5 and 9. We're going to put the square root of 75 here. Pi squared is definitely around here. And then 10 is obviously exactly on the 10. So from least to greatest would be square root of 75, pi squared, and 10. Questions? Ryan, since you missed Friday, how bad are you lost? Because Friday we talked about estimating the square root. Missing yesterday wasn't as bad as missing Friday. We good? Four people have found the distance in miles across the crater using different methods. Their results are given below. Jonathan found 10 over 3. Elaine found 3.45 repeating. Jose found 3.5. LaShonda found the square root of 10. Order the distance from, make sure you read this time, greatest to least. And I'm going to tell you, when you're reading these problems, it's important to read what direction they want them organized. They change it all the time. So make sure you're reading the question. 10 over 3, what is that? 3 1/3. Or 3.333 repeating, right? 3.45, we could put that into a fraction if we wanted to, but it's 3.45. Which one's bigger so far?
3.45.
3.45. What's 3.5 as a decimal?
3.5.
So 3.5 is bigger. 3.45 would be the next biggest. 3.3 would be the least out of the ones that I have so far. Square root of 10. Oh, what am I going to do? What's on each side? 9 and 16, which is 3 and 4. Which is it closer to? It's definitely closer to the 9. It's definitely way less than 3.5. It's probably in the neighborhood of 3.1 or 3.2. Okay? Which one's the smallest? LaShonda should be the smallest. Somebody punch in the square root of 10 on the calculator. 3.1 something, isn't it? Okay. So, greatest is Jose at 3.5. Next greatest is Elaine at 3.45 repeating. Next would be Jonathan at 10 over 3. And the last one would be LaShonda, the square root of 10. Your alarm went off.
It's letting us know that it's a new hour.
It's never happened before, except for yesterday.
Everybody good?